All right, so yesterday, remember, we were using area formulas to find the area from whatever graph we were given to the x-axis. That's what happens when we integrate things. Today, we're going to go on and do it with the calculus methods that we started to learn last year. So it says the fundamental theorem of calculus. The fundamental theorem of calculus is a simple formula to evaluate the exact value of a definite integral. So some of those ones we were doing yesterday were approximate. We were doing rectangles to approximate curves. But we want to be exact where we can. And so calculus helps us do that for most curves. There are some things that we still can't integrate, but we're not going to worry about those just yet. So consider that f of x has a derivative, little f of x. F of x is called the primitive or antiderivative, which means you're going back to the original equation. The definite integral gives a number as the answer, just like yesterday, because it is an area. It may be used carefully to find the area under the curve. So if we have dy over dx equals x to the power of some power n, we learned this last year. If I want to go from a differential equation back to the y equals equation, whatever this x to the power of n is, we add 1 to that power, so it becomes x to the n plus 1, over whatever that power is. So n plus 1 on the bottom. And then because these were indefinite integrals last year, we had to go the plus c, because we couldn't go any further than that at that point. Okay, so that's what we already knew how to do, and we had our constant c. We're going a little step further, because as we learnt yesterday, our definite integrals are going to have numbers on our integral sign. So when we integrate, here's my x to the n in here, I'm still going to add 1 to the power and divide by that power. But when you do that, you put that into square brackets, and the numbers that are on your integral sign here, we write them at the end of those square brackets. Now that then leads into the next step. The next step is that you substitute those numbers into what is inside your square bracket. You start with the top one, so whatever b is, it'll be a number, it won't be a letter most of the time. Okay, so it'll be a number, whatever b is, you sub it in here, so it becomes b to the power of n plus 1 over n plus 1. Then there's always a minus sign, and then you sub in whatever a is into the bracket again. Okay, so it's more of a process. It's not so much a formula. Don't try and sub into that like a formula. It's a process that we do, but that's one way of trying to explain the process of a definite integral. So it says, note, you cannot integrate across an asymptote. So if you know that you have a discontinuous point somewhere in your graph, you can't just integrate across it. It will not give you the correct answer. All right, let's do some questions. Example number 1, A. To integrate, we're going to start with that 3x in there, our function. We are going to leave the 3. The 3 is not very important at this stage. It's all about the x. We have to add 1 to the power of x. At the moment, it's a power of 1. So adding 1 means it's going to become a power of 2. And then put it over that new power. So you add 1 to the power, divide by the power. Remember doing that? Now, instead of the plus c that we did last time, we put this in square brackets, and the numbers from our integral sign go at the end of the bracket. So 3 and 0. Now we're going to sub those numbers in to the 3x squared over 2, starting with the top number, starting with 3. So it'll be 3 times 3 squared over 2. That's subbing the 3 in. Then you put a minus in between, and then you sub the 0 in. So it's 3 times 0 squared over 2. Now, a lot of the time when you sub zeros in, then if everything's multiplied or divided, that whole thing is going to equal 0. But just be careful, because it's not always true. So if you did cos of 0, for example, it is 1, not 0. So just be careful that it is not, that it does indeed cancel out completely. So if you're going to type that into your calculator, what do you get? What did you say, sorry? Yep, or I think that's 13.5, isn't it? As a mixed numeral. Okay, so remember that that is a number that represents the area. It does say in the question, it says evaluate the integrals and draw a diagram. The diagram is not important for the calculation today, but it's just so that you can see a visual of what you have actually done. So if we draw our little diagram now, 3x is a straight line that goes through the origin. The 3 is the steepness, so that means rise 3, run 1, but it's just a rough sketch, something like that. Okay, so if I was integrating between 0 and let's put the 3 there, what I've actually found is that area, or that space in there. Make sense? All right, next one. We are integrating between 2 and 5, 4x minus 3. Okay, we'll worry about the diagram in a minute. Let's do the calculus part. To integrate that, I'm going to do each term separately. So starting with the 4x. With the x, we add 1 to the power and divide by that power. That will simplify, but I'll do that on the next line. Then I move on to the minus 3. How do I add 1 to the power of that? So at the moment it's a 3, it becomes a 1x, because there was no x before, so I've got to add an x in. Close the square bracket, and that is between 2 and 5. Okay, I'm going to just simplify that first fraction before I sub in, because that will make the calculation a little bit nicer. So the 4 over 2 makes 2x squared minus 3x. And now let's sub into that. So sub the 5 in first. 2 times 5 squared minus 3 times 5. Now because there's 2 terms in this, it's good to put my first one subbed in brackets and then go minus. You definitely have to put the second one in brackets so that that minus goes through all of the terms. You can get away with the first one not being in brackets, but it is good to see first one here minus second one there. Okay, so now let's sub in the 2. So it's 2 times 2 squared minus 3 times 2, close bracket, and calculate away. 33, well done. All right, what does that look like on our graph? Let's draw it. 4x minus 3 is a straight line. What's the first point that I would draw? The negative 3, good, the y-intercept. So down here at negative 3, there's going to be my y-intercept. I could find the x-intercept, but remember that the main things I'm looking for are this 2 and this 5 over here, the x values. So if you wanted to show those a bit more accurately, that would be a good idea. So let's put the 2 here and the 5 there. If you sub 2 into the equation, you sub it into here. 4 times 2 is 8, minus 3 is 5. So that would come up to a point here, which would be at 5. And then you sub the 5 in. 4 times 5 is 20, minus 3 is 17. So that's obviously nowhere near to scale, but way up here at 17. There is my line. The area that we have found is this trapezium. And you could check it if you wanted to using the method from yesterday. H over 2, so it would be 3 over 2, bracket, 5 plus 17, and see if you get the same area. All right, next page, question 2. Integrating So equals, we open our square bracket and we're adding to the power and dividing by the power. So it becomes 3x, adding 1 to the power becomes 3 divided by 3. Close your square brackets and put the numbers on the end, the 2 and the 0. It's always the smaller number on the bottom of those integrals. Okay, I'm going to simplify it before I sub in. The 3's will cancel out. And I will just have x cubed between 0 and 2. Let's sub in the top number. That would be 2 cubed. Then we subtract, sub in the bottom number, which is 0. Obviously 0 cubed is nothing, but still good to show that we know what we're doing. 2 cubed is equal to 8. Okay, so this is question 2, which does not ask us to draw a diagram, so we're not going to do that anymore for these ones. That just takes a lot of extra time. We're just going to practice the integrating part. All right, let's just do lots more of these. Is it making sense? Yes, you've been here for 2 seconds, but it makes sense. Good. All right, question 3. Integrating, open the square bracket. The 9 needs to add 1 to become a 9x. The x squared, we add 1 to the power to become a 3, divide by the power, so the 3 on the bottom. Close the square brackets between 0 and 4. Is there anything to simplify? No, so we're going to sub straight into that. Sub the 4 in. I've got 2 terms, so I'm going to use some brackets for this. I'm going to have 9 times 4 minus 4 cubed over 3. That's the first one. Minus, sub the 0 in, which will actually give us nothing, but we're still going to put it down anyway. That whole second bracket will equal to 0. And what does it equal? As a mixed numeral, I got 14 2/3. Do you guys get the same thing? Great. Okay, question 4 onwards, we're going to need to have a few extra strategies up our sleeve because we have brackets and fractions and things appearing. Okay, we are not going to be integrating things that have brackets. Okay, when we were differentiating, we had the product rule, remember? When we had brackets, we could do that, but that does not apply for integrating. So if you have brackets, you need to expand them and then do the whole thing. Okay, so I'm going to expand first, keep my integral sign there between 2 and 5. Expanding will give me x squared plus 2x dot dx. The dx at the end is just reminding you that you're integrating dx. I know it doesn't actually say d, I don't know, bad joke. Okay, so you're integrating dx because you can, when you do a lot more calculus, you will have equations that have more than one variable in them. So you could have an equation that might have x's and y's and t's, whatever could be in there, but it will tell you, whatever this is here, it will tell you which is the variable that you're actually integrating, and the other ones would behave like constants. Okay, so we're integrating the x. Okay, open your square brackets. So the x squared, add 1 to the power, divide by the power. The 2x would become 2x squared over 2. Can I cancel those 2 straight away to just go x squared? Is that okay with everybody? Getting some cancelling happening in my head. Is that all right? Saves an extra step. Okay, and then we are putting our 2 and our 5 on the end. Okay, sub in, start with the 5. We have 5 cubed over 3 plus 5 squared. Put that in some brackets. Then we're going to subtract, sub in the 2. 2 cubed over 3 plus 2 squared. And you guys are all ahead of me because I can hear the calculators. What did you get? 60. Good job. All right, I'll give you a little head start. Question 5. See if you can do it. Expand it out and see if you can then do the integration. Anyone stuck? There is limited space there. So if you're showing every line, make sure you're writing very small. So on the board so far, I have expanded. I actually combined my two middle terms straight away to save me a step. So I would have had a minus 4x and a minus 2x, which gives me the minus 6x in the middle, do my FOIL expansion. Okay. I also skipped a step here because when I integrated my middle term, it would have been negative 6x squared over 2. The 6 over 2 simplifies to a minus 3, so I simplified it straight away. You guys are still relatively new to this. If you need the extra steps, please do them. But is everyone okay to there? Yeah? All right, have you even got the answer? I'm going too slow then. All right, sub it in. We have 3 cubed over 3 minus 3 times 3 squared plus 8 times 3. There's the first one. And then minus, then all the zeros. 0 cubed over 3 minus 3 times 0 squared plus 8 times 0. So it's really just the first bracket, which gives you a 6. All good? Wonderful. All right. What else can we do to make this a bit different? Fractions. Okay. So fractions, again, we're not going to integrate fractions, so we have to simplify them. Now, if I have two terms on the top, each of those terms needs to be divided by the x cubed. I'm going to cancel it out. Okay, so let's do that before we try to integrate anything. So leave your integral sign, the 1 and the 3. 3x to the 5 divided by the x cubed, you cancel 3 of them off, would be 3x squared. Then this x cubed is going to cancel that x cubed, so you just have a minus 5 for your second term. And then you still have that little dx sitting at the end. All right, now it is back to the ones we were doing in question 1 or 2. All right, so let's integrate. Square brackets. 3x, it'll become a power of 3 over 3. Can we cancel those 3's? Yes. So that would become x cubed. Does anyone still need me to write that down? Is anyone getting lost when I'm doing? All right. So what I've done is I've kept the 3x cubed, add 1 to the power, divide by the power. But all I'm trying to do is cancel those 3's off straight away. Yeah. Okay. Then the minus 5, I need to add next to that. So minus 5x, that's between 1 and 3. Okay. Sub in the 3 first. It would be 3 cubed minus 5 times 3 minus, sub the 1 in, 1 cubed minus 5 times 1. What's the answer? 16. Perfect. All right, I'll give you another little head start. See if you can do question 7. Be careful subbing this when you calculate all those minus signs and things in there. What'd you get? 10 is correct. Anyone get lost? Now, it's probably the minus signs. So you minuses, like brackets are at the minus 2 squared, and the minus 3 needs to be in brackets squared. You missed an x? Oh, when they cancel, it will leave a 1 though. Because x to the 5 divided by x to the 5 is a 1, and then you integrate that to become an x. Make sense? Yeah, so just be careful back here, a couple of people. If you're dividing this x to the 5s, it does leave a 1. It doesn't disappear altogether. Don't lose the 1. Alright, next page. Question 8. Alright, these ones are here because they involve negative powers, but that's no worries to us. We can do that. So this first one, don't need to do any rearranging. We can do it straight away. But when you add 1 to the power, remember from -4, it's going to become no, that's going to be smaller. -3. That's what you've got to be careful of with negative powers. So it's x to the -3 over -3 between 2 and 6. And then sub in. Just be really careful with those minus signs. If you want to, if you're looking at this going, I think that's going to be a really yucky thing to type in my calculator, boys. You can change it out of those negative powers like this. That x to the -3, it would be -1 over 3x cubed. And then it's in a fractional form that we're more used to dealing with. But you can do it from either way. If you're comfortable with the negative powers, go for it. So subbing in, we have got -1 over 3 times 6 cubed minus, because there's a minus that I have to always put in, and then it's minus is my in here. So it actually becomes a plus, but I'm putting them both there so you can see it. 1 over 3 times 2 cubed. Alright? I did it from this one, but you could have done it from there. That's okay. You should still get the same answer. What did you get?
13 over 3.
Yeah. Okay, but while we have fractions, we can't integrate. This one though, there's no x's that you can cancel out on the top and bottom, but you can bring that x up and give it a negative power so that you can integrate it. So that would be integrating between 1 and 3. The 2 is the same, but the x comes up to be x to the power of -6 dx. Okay, now it's like question 8. Put it in some square brackets, keep the 2, add 1 to the power, makes -5, good, over -5 between 1 and 3. What do you think? Do you want to leave it with the negative power or do you want to change it back into this form? What's your preference? No one has a preference. What was that, Grace?
I was just checking for the sentence.
Have you guys done this already?
Yes.
What did you do? Did you leave it like that? Or did you change it? You left it. You guys left it? All right, let's leave it. So we're going to sub in and we're going to have 2 times 3 to the power of -5 over -5 minus 2 times 1 to the power of -5 over -5. And you should get 484 over 1215. Yeah? Did we all get there in the end? Wonderful.